So today I'm your speaker, and I'm going to talk about customizing fall manure applications for your soil type. So talking a bit about soil and how that relates to things. And just a little bit of background for those who I don't know. I have my all of my degrees, so my bachelor's, master's, and PhD all in animal science, and the last 2 degrees had a focus on environmental management of livestock, so nutrient management essentially. And that's what I do here at the district. I do nutrient management, guidance, and tool development and research related to that. And so today I'm going to talk about a lot of the programs and various things that we've developed in order to help risk management with manure application in those areas. So let's get started. So what I'm going to talk about a little bit first, what is the issue, what are some of the resource concerns, and what has kind of driven the program and the issues that we involve ourselves with and that we talk about, and that the dairy industry in particular has to pay attention to and mitigate against. Talking about soil types and manure application, how to customize that together to make a really customized program on your operation to minimize the impact of both of those resources, and then the tools about that, and when should you be applying based on your soil type. Also, there'll be time for discussion and questions at the end, but as I go through, please feel free to interrupt at any time if you'd like more clarity or you have a question on something I've said. So first of all, here's Whatcom County, and this map just illustrates the amount of surface water, which would be all the little blue lines, and the large amount of groundwater we have. This dark blue represents the Sumas aquifer, and you can see it's over a large region. All of the red dots represent the dairy operations, plus or minus, in the region, and you can see that there's an overlay of all of those things together. So there's quite a bit of potential impacts there with what we've got. So we've got, of course, the dairy operations in that area. We also have a lot of cropland of various kinds, berries and potatoes and wheat and other things. We've got salmon as well in those reaches and shellfish and our resources. And those what kind of drive why we really need to focus on the groundwater and surface water impacts, because these are also industries. Salmon and shellfish, they're also farming industries. And so they are impacted by what comes downstream as much as those upstream when you've got negative nutrient values in those other resources. So there is kind of a whole spectrum that we do have to pay attention to and what drives what we're looking at here. So why is there an issue with involving nutrient management, and where does kind of that disconnect come from? Well, number one, you have cows, and they make a lot of manure as a byproduct, or almost milk seems like your byproduct in some cases. And the manure balance here, when we're looking at nutrients, nitrogen and phosphorus, is there's typically far more phosphorus that's produced per unit of nitrogen. And we usually use nitrogen as the balancing factor when you apply to your crops. And so a lot of times we can be out of balance there. The phosphorus and your potassium as well is higher naturally in your manure. So you apply this to your crops, and then there's uptake by those crops and return in a lot of your nutrients as grain and forage. What's not taken up and returned is usually in excess, and you can lose that via nutrients, sediments, pathogens, whatever's coming off of that field, depending on how you put it on, which is where we're really going to focus the talk today. But you can lose these a different way. You can have it in soil in excess. Some of that will be returned later and applied as nutrients to crops. The rest can be lost in runoff or just hang out to be lost in some of these other pathways. You can have air losses, so that would be volatilization of nitrogen as ammonia off your field, so you can lose some of your nitrogen that way. And surface water and groundwater, which I'll focus on a little bit more, but those are definitely where we try to minimize our losses and kind of focus on these two on the runoff perspective from the field surface, as well as the groundwater that would be leaching what's lost below the root zone. And those two things are definitely predicated on your soil type and then how you treat your nutrient application timing and rate and methods on those soil types. And that can make a huge difference on your loss pathways. And the loss, by the way, we talk about it from an environmental perspective, but it's really important from a farming perspective as well to maximize your yields, maximize what's there and available for your crops. So yes, some folks are in excess of nutrients quite often, but there's a lot of people who are don't have enough, and so you've got to manage it so that you have optimal uptake for everything. You don't want to be buying fertilizer if you don't have to, and in a dairy system you really shouldn't have to. So what factors lead to a pollution event that kind of we have to pay attention to when thinking about customizing these different soil types and application timings, etc.? Well, number one, as we just talked about, is availability. It's got to be there. So if you have application in excess or at the wrong time of year, that means you have something available to move one way or another. The other one that would be linked to improper manure application and grazing practices, whether that be timing, method, or rate. So you may put it on at the right time, but you put way too much on. Or you may put way too much at the right time, but there's just too much there. Either way, you may not be getting enough, and so you've got crop deficiencies, etc. Your method during the time of year makes a big difference as well for your potential losses on different soil types. Very important. And then you need some type of a catalyst. That would be a weather event. Something like precipitation, flooding, high water tables, wind, all of those things, depending on the method of application you're using and the time of year, are going to affect, is something going to be pushed down with too much precipitation through a very kind of coarse soil profile like sand, or is it going to go off the surface on a tighter profile like a clay? So you really do need to consider that with your weather events and what time you applied that. And then, of course, poor field conditions. If you're applying when your crop is very sparse and there's not a lot of density, it's going to be able to move much quicker off your field. Your infiltration rate will be a lot slower. Those make a big difference. If you're obviously applying on saturated soils, that manure can't go in the soil profile. It can just go off of it. And all this is highly related to your soil type. And so let's focus a little bit more on that. So there's three main types of soil types, if you will, and these determine your texture and the physical properties of that soil. So we've got sand, silt, and clay. Sand being, if you think about them just generally, you can think of sand being kind of large, irregular particle sizes. So you're going to have a lot of pore space between those larger particles. Silt's going to kind of be in the middle and variable, and then clay is going to be very small particles, and so those are going to settle a lot closer to each other, and you're not going to have a lot of pore space between them. And that makes a big difference when we start talking about infiltration and those types of factors, which I'll go into next. But just in your brain, you can kind of think of that. Sand are large irregulars, clay are very small particles, and silt somewhere in the middle of that. And another important characteristic is the soil structure, so how that soil lays up. And that kind of determines the overall water movement properties and the rooting depth of that. So you can have all sorts of different soil structures. Things to think about are like granular, so that would just be like a bucket of sand. It's very kind of loose and mobile. You can think of platy and blocky structures. Massive structures, which massive would be just kind of like really condensed soil like clay that has been worked and worked and worked, and there's going to be very little ability for rooting depth and movement through there. So those make a difference with your structures. So the main soil characteristics that we think about from a water infiltration perspective is one is infiltration, so this is kind of like your drainage rate, and this is the ability for water to move from the surface into the soil. So that has a lot to do with that upper profile. How are you treating that? Is it compacted when therefore it can't get through there? And we see that a lot at different times on different soil types. Like if in the wintertime, if you get a lot of waterfowl on your surface and it's kind of wet already, they're going to compact that most likely, and you're not going to be able to get water infiltration because of that. If it's saturated, you're not going to get that in there neither. So different soil types, like sand for instance, allows good infiltration into that surface as long as it's broken up, or even a silt is going to allow that, at least that top layer, to get in if that's been treated well, if you haven't compacted that surface. Permeability is the ability for water to move from there through the soil profile. How quickly is it running through into that root zone and past it? Again, a sand is going to be able to go right through that. You can think of it like those large particles, big pore sizes, kind of like a sieve straight through. Whereas something like clay that's really tight isn't going to allow that permeability so quickly. It's going to really kind of hold on to that water as it go through. It can block that up, and so that's when you get standing water on your surface. It can't get through. Even if it gets through the top part of infiltration, you can't get that permeability through there. And that relates to the water holding capacity. So that's the ability of a soil to hold water and reach saturation. And that is a function of that texture. So clay, for instance, has a very high water holding capacity. It wants to hold it. In other words, it doesn't let it go through. Like sand has a very low water holding capacity. It runs right through the soil. So you can think of it in that way. How well does it hold on to it? And so the higher it is, that's good certain times of the year. When you want that water available for your plants, it's going to stay in some soil textures, like more clay type soils. But that's not going to be great when we're worried about potential runoff issues. But you don't have to worry about leaching so much. Whereas in like a sandy soil, it's not going to hold on. You're going to have to irrigate far more because there isn't a lot of water holding capacity on those particles. But you're not so worried about having a runoff or a runoff issue, but you definitely worry about leaching through there. So these few little perspectives, when you think of your soil types, you can start kind of building when you may have a problem, when you just start thinking about these very simple things and how they relate to those 3 different main soil types. And I realize this is a little bit small, and I can give you a copy if you want, but this table just kind of documents sand, silt, and clay in some of those various capacities. So water holding capacity, drainage rate, soil organic matter, some of these things, and how you do have kind of low, medium, high on a lot of these aspects. And you can kind of see that, that I kind of just went through kind of specifically. So we talked about that water holding capacity, low for sand, high for something like clay, whereas the drainage rate is going to be opposite, very high for sand and very slow for clay. But compactability, again, that's when you kind of think of that, very low for the sand soils, very high for the clay. Silt is always going to be kind of right in the middle of those two, so you kind of have a gradient for most of these things that you look at. And some things that are important for crops, resistance to pH change, ability to store plant nutrients. And that's an interesting one, and if you think about it, that's very low for sand, very high for clay. And why would that be, can you think? It's most likely related to that water holding capacity. It also has something to do with the chemical charge on there, and I'll talk about that a little bit more as well. But that's important, is that this clay soil has all these great potentials to it, but also has these really high detriments to it if we're not kind of managing it correctly at the right time of year. And same with soil. There's some really great things about it from a water management perspective, but from a cropping perspective, it can be a bit challenging. So very important to consider. When we talk about nutrients and where they're going in these soils at what time of year, we're going to think of 3 major ones: ammonia, nitrate, and phosphorus, kind of the biggest ones. And ammonia is what you put on with your manure. That's what's in your manure. You put on kind of organic nitrogen and ammonia nitrogen, and it's going to convert in the soil. That organic nitrogen converts to ammonia, and then all that ammonium nitrogen converts then to nitrate. But while it's there, ammonium typically is in the upper layers of the soil, and it can be lost with volatilization if it's not incorporated. So if you put it all straight on the surface and you have no way to incorporate that with rain or with aeration or kind of using injection or any type of tillage on your corn, etc., getting that in there, you can have that loss of nitrogen as ammonia gas to the air. So that's a negative. The other would be that you have that quick conversion, which is a very positive thing, because nitrate is what your plants are looking for. So you want to make sure it stays in that upper profile. You're not pushing it down too fast or losing it too readily, surface losses, and then it's not available for plants. So it's good that we want it right there. Once it turns into nitrate, you want to make sure that that timing happens at the right time, that you're putting on that ammonia, and there is a lag time depending on the soil temperature and the microbe effects and all those things, and how quickly that ammonia nitrogen is converted to nitrate. Once it does, you want it to be able to be taken up by plants at their maximum growth times. So if you put this on at times when plants aren't growing very quickly, you're likely to still have that conversion, but not the plant uptake, and so you have that available for losses. So nitrate typically moves quickly with water. It just likes to be attracted due to the charges on there. So it binds to water, and if we think about what type of soil would be more prone to having losses, very leaching, It's going to be our sandy soils with large pore spaces where water can just shoot right through there. So that's where we tend to see a lot of that losses of nitrate right through those coarse pore spaces and the textures, and it gets below that root zone, and then it's available to be lost when the water table comes up. So that's really important. This can also be lost in other soil types like our clay, where it gets super saturated and wet, or the surface water table comes up high. Then you have conversion via denitrification, which is when it becomes anaerobic, so there's no oxygen in the soil to turn it to nitrate and keep it there. It actually, that nitrate turns into nitrogen gas or something along that way, and it's lost to the air. So you can lose nitrogen a few different ways if it's there and it's not being taken up by crops, and you're going to kind of lose it in ways you don't want to. The next one is phosphorus, and phosphorus doesn't really bind to the water, it doesn't shoot through things. It tends to stay in that surface, that kind of top area of your soil. It does leach a little bit, it's very slow when it does, and it's not a great value. We've seen it more in sandy soils. It can move a little bit better. In clay soils, you're not going to get much downward losses at all. Most, if you're going to get losses, it's going to be off of that surface. So if you've got flooding in your area, or you're losing a lot of that soil from the top layer, that's where your phosphorus is going to go. And that's, you don't want it to move that way. Yes, we do tend to put it on an excess, so you do tend to have the capacity to lose it very easily that way if your crop isn't taking it up. You can manage your phosphorus a handful of different ways. You can have crops that take up more, like corn will take up more than grass. It has a higher phosphorus requirement. And there's some other crops you can work with when we've got fields with high phosphorus, which in our area we tend to. Historic manure applications is going to have more phosphorus in it than thin manure, etc. So there are ways that it can move. So if you think about anywhere you'd have sediment losses, that's probably where your phosphorus is going to be lost too as well. So in this, as I mentioned, with more dense soils like the clay ones, you're going to have more available on the surface for loss. So let's talk a little bit from the perspective not of maybe the soil type, but of the resource concern, so the surface water and the leaching aspect and how that functions into that. So first of all, surface water runoff occurs when either precipitation or over-irrigation, that's also a big one, carries the nutrient from the surface of your field. So it's going somewhere. That can be to a creek, a ditch, a river, something of that nature. It can just be to your other fields or somewhere else. You want it to stay where you put it. You put it there for a reason, and you want it for your crops. So no matter where it's moving to, we just want to limit that movement no matter what. So high-risk soils are going to be those small particles, as I mentioned. So the clay-type soils with small pore spaces and saturated soil. So a saturated soil can be any soil. If you have over-applied to that surface, or the water table's up and the silts and various things, that's where you're going to definitely have an issue, any saturated soil. So when should you be concerned? High precipitation months, obviously. We start getting precipitation that occurs kind of in that September time period, year pending. Last year we had 0. Who knows what we'll get this year? And then as it goes through into October, we get a little bit more, et cetera, et cetera. So as the year goes on and that soil starts to saturate because it reaches that water holding capacity, it reaches its infiltration rate, all those things kind of max out, then you have the ability to have a runoff event. So if you think about that, you don't want to be applying manure onto soils that are going to be readily saturated or already have that tight texture where your moisture has been reached. So thinking about that. Obviously a large rain event, no matter what the soil, can move something right off of your field. It doesn't matter. Over irrigation is the same. That can be equated to similar to like a large rain event. So anything in excess of the infiltration rate. So your soil can still have a decent infiltration rate and it's trying to get that water down there, but if the rainfall is greater than that, it has to go somewhere and it's going to want to go off your surface. If you have a really dense crop on there, your forage is at really high density, that'll be slower. If you've got a bare field, a fallow field, or really poor vegetation, you had a lot of maybe kill that happened over the winter, then it's going to be able to move quicker. So forage management, crop management on top is very important as well. Having cover crops on your cornfields in the wintertime so we don't have fallow fields, also really important. And then, as I mentioned, saturated soil. So as that seasonal high water table comes up, which it does in many, many of our soils, that space between the two gets less and less, and the ability for water to get in there also gets harder and harder, so it saturates. If you've got 8 feet, you can have that water get down there. Even if it's slow, it can still drain down. If you've got 2 feet, it's going to max out at some point, just like a sponge. It becomes saturated. The thicker your sponge, the more water you can put on before it starts dripping out of it. So same idea. So when we think about groundwater and the leaching losses, so this is losses below the root zone. Same thing, we think about precipitation and irrigation. We need some type of catalyst to try to move all of those nutrients out of where we want them. So this is where that water will push the nutrient below the root zone and into the groundwater profile at some point. So whether the groundwater comes up to meet it or you have enough rain that it pushes it down to the groundwater, it's going to be one or the other. So here for high-risk soils are going to be large particles. So this is where our sandy soils are going to have the greatest potential for leaching losses. So again, it's that large pore spaces, or you can have preferential pathways through there. So if you've got a field that is actually hasn't been messed with for a long time, low tillage on there, and you've got a lot of good wormholes and all that going on in there, that's really great for aeration and various things, very good for your soil profile, but that also creates pore spaces for water to move more quickly through your soil. So you just have to be cognizant of that and apply at times where you're not going to have those losses be so great. So the other one is soils with that low water holding capacity, where those particles can't hold on to that water and it just shoots right through. So those are your higher risk soils. So when should you be concerned about groundwater leaching? This is precipitation in the fall is when we're most concerned. And that's because you've had relatively dry soils. So those pore spaces are quite large at that time when the soils are dry if you haven't been irrigating. Actually, irrigation too will push it through quicker through the summer than it will later on when you have kind of slower, as that soils kind of saturate, it's a little bit slower and they can actually hold water a little longer. If you're not keeping up with your irrigation, your soil dries out before you irrigate every time. It's just like having a fall precipitation event every single time you irrigate. You have dry, large pore spaces, your soil can't grab that water fast enough because it's too dry to do so, and the pore spaces are larger, so it'll go right through. Something again with that preferential flow pattern as well. So when you've got all those wormholes and various things that can just shoot right through, when nutrients are available. So this is also that fall time. Your crop growth is declining. You've either taken your corn off and your cover crop is slowly coming in, or at the end of the season for grass, it really starts declining after September in particular. The grass growth, we still get a little, but it's very, very slow. And so the availability of nutrients is there, particularly if you've put on late in the season. If you think about, there's about 1 to 3 months lag time in conversion of the nitrogen and manure into the plant usable form, depending on how warm the soil is, etc. It's going to be a little quicker at the end of the season. So that conversion is still happening, and it's still happening readily, but your plants aren't taking it up. So there's definitely typically an excess at the end of the year. If you've got that on soils with large particles and big pore spaces, it's just going to shoot right through because your plants can't grab it. So that's also a big deal, as I mentioned, when soil moisture is low, so that it can kind of go through. Your water isn't quite being taken up right in the beginning. Once it starts saturating a little bit, it'll take it up quite nicely in that early, kind of later in that fall, kind of early winter season. And then when the water table is near the surface. So usually it's coming up in the fall, but we're definitely up by like February time period. So being cognizant of that, of when you're putting on and when that conversion rate happens and where that water table is. It's a lot to think about all at once. So when you think about your manure, when you're putting that on, based on your soil type, so you've thought about your soil type, and we'll go over this again. So you've thought about your soil type and what its issues are, when you should be putting it on. Well, the next part is to think about your manure. And this is the hard part to match up, because typically the nutrient concentration of the manure, so we just think of like in a 1 gallon sample, In January, it's going to be very low concentration because we have so much dilution from rainwater, or even if you go further and further in. So you're going to get a lot of dilution, whereas later, so in July, August, when we don't have rainwater input and the clean water input's a lot less, that same gallon's going to have a lot more nutrient to it. So you have to think about that when you're applying, is applying on a nutrient basis, not necessarily a gallon basis solely. So you're like, oh, I'll just put out 10,000 gallons. Well, 10,000 gallons in February is very different than 10,000 gallons in August. So really being cognizant of that. And also the viscosity, so the thin versus thick stuff. The hard part is it's thin in January, it's thick in August, and we want opposite. So when you put on in the early season to the soils that can take it, you actually want thick, nutrient-dense stuff. And later in the season, you actually want that thin, dilute manure. So unfortunately, that's not what we get because of management, but it's what you want. So figuring out how to pump out of your lagoon in the early season in such a way that you get that thicker stuff is challenging, and diluting it at the end of the season can be expensive from just a clean water perspective, but that's what you need to do. So you have to adjust your gallons there in various things. So a bit of a challenge for what you're given versus what you actually want to be applying and what you need. And again, that's also going to be very specific to your soil type. Throughout the year, we want the thick stuff on those very permeable soils like sand. We want the thinner stuff on those less permeable soils like clay at certain times of the year. So you can think about that as well, what you're putting on and when. So matching soil type to application. So let's do kind of each one of these sectors a little bit individually. So when we think about the sand, that's that high permeability, high leaching, low runoff. And this means it doesn't hold onto nutrients or water nearly as well. So you have high irrigation and higher nutrient needs on a different kind of basis. So that's where we want that thicker stuff on there so it's not thin and pushing it through as well. The nutrient conversion rate is higher, so the rate at which the nitrate or ammonia nitrogen converts to nitrate can be higher because there's more oxygen in those soil types. There's more microbial action. Those soil types can actually kind of support a warmer pore space in there at certain times of the year. So you're going to have typically a higher conversion rate, seasonal dependent. So here's where, in these types of very sandy soils, we're saying start your application actually in mid-January. So not thinking about that February or T-SUM, but actually getting it out a little bit earlier on soils that can take it that are low-risk fields, and I'll talk about that. So on those low-risk fields, get out there early so that as the conversion rate starts, as your soils warm up above 40 degrees and the microbes start converting all that manure and nitrogen into a usable plant form, your grass growth curve is about the exact same. So your availability and your conversion and your needs all kind of correlate to each other. And you've got that thicker stuff out there. We're not worried about it being lost as readily. You're going to get a little bit of push, but it's not going to be as much at that time of year. So very important to consider. But on these soils, you need to stop your application in late August. Applying after that, and we've done studies, and I can show you this, actually has no benefit to your crop. Whether you apply through October or you stop in August, you get no benefit. If you start early in January versus waiting till later February, you get a huge benefit. So that's important to note, is that here, when we ask you to stop in August, the only challenge for you is managing your storage. So you're not doing anything after that time period on these highly sandy soils is essentially waste disposal. It's not nutrient utilization. So very important to consider. And a silty soil, so this is going to go in the middle somewhere. So these are kind of harder to kind of classify. They're going to be medium permeability, medium runoff, medium in everything. These are the soils that, depending on where they fall on here, so it's characteristic of how much sand and clay combo, and all these are the same, by the way. So here's kind of a chart that shows the percentage of silt, percentage of clay, and percentage of sand, and you'll kind of fall in there. Obviously, you know, if you have a soil in here, you're doing great. You've got the benefits of and the characteristics of all these. If you're farther on the silt, the clay, or the sand, you have to consider those appropriately. So wherever you fall on here for a silt is going to determine, are you more in the sandy and permeable zone, or are you more in the clay and non-permeable area? So those soils have to be considered individually. And everyone on your dairy nutrient management plan, you've got a map that shows all your specific soil types, so you can actually say, oh, I've got a this, and I've got a that, and I've got a this. And so you know where they fall on that spectrum and how to manage them a little bit easier. So that's a nice way to be able to figure that out in your brain once you know, in particular, how clay and sand really vary, and then you grab your silt and you figure out which one is closer to it. And then, of course, the clay. So that other end, this is our low permeability, low infiltration rate, high runoff, especially when saturated. I mean, you see standing water in fields all the time. A lot of these are somewhere in that zone. So, the reason that, by the way, when I said clay holds on to nutrients, this has a lot to do with chemistry. And without going too far, we'll just say some have negative charge, some have positive charge, and those two, when brought together, really like each other. So two negatives aren't going to hang out, two positives aren't going to hang out, but the positive and negative will tend to bond together. So clay being negative, it's going to hold on to nutrients with a positive charge, like ammonium. So, and as well as having that tight pore space, those nutrients aren't going to be lost as readily in either. So it's going to hang on to that. How it does lose nutrients is through denitrification. So if you've got excess on there at the end of the season and your soil saturates, which it typically will in a clay, you're going to lose that with denitrification up to the air. So come spring, it's not going to be necessarily available if you haven't managed that soil right. Things like putting in drainage and those types of things are going to help a lot for minimizing the amount of denitrification and maximizing the retention of that nutrients, because it's really hard to get out in these fields in the early season. I mean, you have to wait and wait and wait and wait till you can get out there. So if you've got that stuff on from late the previous season, the conversion is going to happen slower as you go through. So timing exactly when you get out to clay type soils the latest you can, so it's there the next year, and then getting on as early as you can based on your equipment use is going to be really important for managing these soils. They're probably the trickiest of all of them. So these ones, as we mentioned, you're going to have to start application late and stopping application. These are the ones you can go longer into October for sure. If you're in the floodplain, though, you need to get off a little bit sooner unless you're doing some type of an incorporation method, and you can get those nutrients into that soil profile a little bit faster. Otherwise, a flood comes, it's just going to take everything that was on that surface right with it. So you've lost it no matter what. You've actually just applied to the river or whatever it is in some cases. So how do you determine when to apply exactly for all these soils? So you've kind of determined, okay, I've got these soils and these soils and these soils, and I'm going to group them into these different types of categories. And so what we've got are a few different ways to help you understand what are those soil types, where do they go, are they high risk or low risk, am I worried about this or that? We've created a system to help you do that, and then help you decide for those specific fields and soil types, when should I be applying to them, at what time of year, what do I look at, how do I determine these things, and then what are some real-time ways that I can look at this on a daily basis. So we've created all the tools to help you kind of understand this and do this whole system a lot better. So the first one is we've created what's generally what we call as ARM, or Application Risk Management, which looks at all these different pieces. So this is a system to look at runoff and groundwater leaching together in your dairy nutrient management plan as part of that, and to give you this kind of guidance on a spatial, meaning each individual field, and temporal, meaning a season by season or day by day perspective and risk analysis. Every single day you can figure out what is the risk for that specific field. So you can know exactly when you can get out there, when you should stop being out there. And we've got real-time guidance that helps with that in a few different ways: maps, worksheets, and tools. And I'll kind of go over each one of those. So the first one is having this field risk assessment map that I mentioned earlier. And I'll show you what it looks like for runoff. It's going to look a little bit opposite for a leaching perspective. So this is basically, we look at all of your fields and we take all that soils information that I just kind of briefly went over. We use like 15 different factors about that soil type and a visual field assessment, because even though, classification on paper, it may be something, you may have, a field out there that's got great drainage that's going to help, or it's way compacted from bad management potentially over time. So all those factors have to be considered, and then you get a risk rating, a high, a medium, or low. Your crop difference. So for instance, a high risk field may be a bare ground or a very compacted field. You've got water right next to it, so we definitely have somewhere where we're definitely worried about runoff happening. You've got a high water table, maybe flooding on that field. It's going to be like a clay type of soil most likely. Whereas you've got low risk fields, so you've got maybe it's grass and it's forage, so we've got something on there all year round. So good surface breakup and flow reduction. There's no adjacent water, we've got great infiltration. So these are the ones, maybe it's more of a sandy type of a soil. So that's kind of a characteristic there. And how this would look, so here's just 4 different farms. And you can see you can be very lucky and be in an area where you've got very low runoff, although if you flip this map to their leaching, they have very high leaching risk. So their timing for the majority of their practice is going to be shifted from like the January to August time period. You can have an area where you've got very high risk fields. Maybe you've got a couple low, so you've got a whole swath of fields that you need to manage based on that more high risk. So for runoff, so we're going to think about, okay, we need to maybe shift things out a little bit, and maybe you condense both ways if you're in that medium. So you get on a little bit late, but you need to stop a little bit because we're kind of in the medium for runoff and leaching together. So having that custom in those kind of yellowy medium fields. Floodplain, you're going to probably be in a high risk factor just from that perspective, but that doesn't mean our early season management isn't going to be a little different. Maybe you get out there a little bit different timing, a little different rate. You're going to have to use maybe different equipment so we can get that in a lot quicker rather than surface applying and having it more available. So that's really going to affect maybe how you get it on. And you can just have a mix of different ones all together in a very short period, maybe due to topography. You kind of go down and you go back up. So all these things where you're at is really going to change what your field looks like. But you definitely get an idea. Here are my low risk fields for runoff. Here are my high risk fields. I need to manage these this way, and I need to manage these this way. In even one field, you may have a couple different risk factors because a lot of our fields have multiple soil types. They tend to be pretty closely related when they're on a field, but definitely you can have a little bit of a change through there, and that changes your management as well. So that's kind of the looking at those maps and figuring out what fields you can start looking at what time of year, and then what you'll do is you fill out a worksheet, and this is available on our website. And this is basically Excel based, and as you go through you're going to enter in your information, one of those being what is your soil type, so that we can adjust all the background calculations as you go through. The next is what is the forecast, and we're going to talk quite a bit more about this since this is kind of your first line of defense. If it's dry, you can manage things a lot different than if there's a big rain event coming. And you know, historically it's like, oh, rain's coming, I should probably get out. No, we're going to shift that thought process around, say a big rain event is coming, you can wait, here's the forecast, this is when you'll be able to get out. So shifting that paradigm and thought process a little bit is extremely important for not only keeping those nutrients on your field, but preventing any type of a loss pathway as well. Looking at the water table depth, this is going to tell us how much space we have in that soil for that infiltration to occur, as well as the moisture level. Very important. What is that soil moisture percent? Are we going to have potential issue with it running off because it can't get down? Or is it still, even though we've got a decent rain event, if your soil moisture is pretty low, we can assume we're going to have a lot better infiltration rate. So that's important to think about those two things paired together. What are those field conditions? Do you already have ponding out there? Is it flooding? Is it frozen? All those things obviously are very important and obvious factors on are we going to have a loss pathway? Are you going to be compacting your field? Are there areas you need to avoid? So important to think about. What is the vegetation cover? This is that density factor I talked about. The more dense your vegetation is, the slower that water is going to take to get off your field because it's got to move around and here and there and the other. If it's really sparse, it's going to be able to just move really quickly. So having that dense vegetation is important. That also means you probably have better rooting and infiltration into your field. The more mature your grass is, the bigger that root profile is probably going to be and the better your water infiltration will be. If your roots only go a little way, it's going to be really quick pushing that nutrient down before it's going to be available for loss below that. So having those mature forage stands or a crop that has a nice rooting depth is also important to consider. What type of equipment are you using? Are you using a big gun because your field is relatively saturated and therefore you're only applying to the surface? That might be okay on certain soil types, certain times of year, maybe not at others. So if we're expecting a decent amount of rain, or if it's quite warm, you're going to have probably a lot of volatilization losses when it's warm, because all that manure is right on the surface and you're spraying it, so you get a lot of lost pathways, so you're not maximizing your nutrient use. Or you're going to apply it on the surface by pulling, and if you're not managing that, you forget about it, you run to lunch, and suddenly you put on 3 times more than you mean to in one spot, and so you're going to be able just to move it right off. So managing that can be a little tricky, but it can absolutely be done effectively if you're a good manager of that. Using an injector on your corn is great. You're getting all that nutrient right into the profile. Very little is on the surface for loss, and you're going to have very little nitrogen lost as ammonia as well. So really good means. Using an aerator, so being able to kind of puncture that soil as you go through on grass is going to help that manure get in. We really encourage this in the early season, especially in that January, February time period, because you'll get it into that soil a little bit quicker, and it's not going to be lost here and there and otherwhere. And especially sometimes the soil's still kind of tight because it's cold, maybe it's a little bit frozen, so you can get it in a little bit quicker so that it's not hanging out on the surface. Also good in the late season on some soils like clays to kind of break it up a little bit more and to be able to kind of get that manure down a little bit before it can have a chance to run off. So always a good opportunity and option to use that method a lot of times of the year. The next one, or any type of a vegetative treatment, or are you using our seasonal setbacks? This is just what type of protective measures do you have in place, essentially. So all those things make a difference. If you're in a high-risk area, like you've got a water body nearby or something of that nature, you've got something there, and that's basically your insurance policy. In a way to say, yeah, I can apply later because I've got this, or during this type of a high-risk season. If you're applying right up to the ditch, your chances for having a runoff issue are very high, but if you're saying, well, I'm 80 feet back, then your chances are actually quite low. So just putting something as simple as a setback distance, so that's just the distance from a resource concern, a water body, whatever it is, to your edge of your manure application, that alone is a huge, an easy thing to do. It makes a huge benefit and difference. So at the end, what this worksheet will do is it will give you a risk for applying on that day to that specific field or group of fields that have that similar soil type. So you'd want to do this for each one of your fields that have a different type of a soil. And that'll say, okay, today you're low risk, have at it. Everything looks great, go put out. Or you've got something in there that said, nope, this is high risk. And you can go back up and look and say, well, these are all low and that's low. And you go back up and you say, oh, my soil moisture is 96% or whatever. That's obviously what's stopping me. And that's something you can start paying attention to for that soil type. And you can say, oh, so these other factors I'm okay with, I can start really focusing on that one value. How can I decrease that? Or there management and characteristics I can do to help improve that part of that soil type? Sometimes there isn't, sometimes there is. So there's different management options that you would have to be able to adjust some of those so you can utilize that crop and those yields are better and everything else is better on that field. So what we found, by the way, so as I mentioned, we've done some local trials with this on fields, and we've looked primarily at this time on sandy fields. We had one field as well that was a little bit more of a higher type of a silt and clay proportion to it. And what we found, as I mentioned, is that for yield differences, if we stopped in October versus stopping in August, we saw no difference throughout that time period and into January. In fact, what you would probably see is you would have, and Steve Franson talked about this, we've had a couple other speakers who have come in and talked about this, as well as that you actually can encourage winter kill if you apply through October, because the plant isn't putting its energy into its roots, it's putting more energy into the top growth, and therefore it's not going to have great survivability if it hasn't basically kind of put its nutrients into the bank and its root systems. So you can actually harm your crop by applying too late on certain types of soils. But as I mentioned, what we found is when we started applying earlier in the season, so we try to match things up, we got thicker stuff on earlier, is we saw an increase in forage yield from 10 to 40% in those fields, and the density was much, much greater, about 25% more density in that forage as well. So it wasn't that it was taller, it was that there was more of it. It was just more dense. And when you split fields, same management, same field, same everything. So we're definitely able to look at that really positive thing that we saw there. So that's where your yield has the biggest difference, is how soon and how well you can get on that soil type, not how late you put it out. So just late in the season typically is a negative. So as I mentioned as well, what we saw, and I'll show you a few graphs of this, is that positive, that fall application, by reducing it, we saw significant less nitrate leaching in those soils. So if you keep applying on those sandy soils all the way through October, your nitrate losses are going to be much greater. So that tells us that you're putting it out there still, but it's not being utilized by your crop. It's just being lost. So that was a negative, and we saw that actually we had reduced probability as well with that early season application, because you find a window of dry weather. We always have it, almost, in January. It's very, very common. And if you wait too long, you're in late February and it just rain, 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 rain. But if you can catch this one time period and you put it on with the right type of equipment on these specific soil types, it works really well. So that's kind of in those sandier soils. We've done a bit of work on that to definitely look at how that works out. We're going to look at more high-risk soils this coming year to be able to get that more customized as well. So a little bit small here, but essentially if you look at the orange and yellow dots, and what you're looking here is we've got dates along the bottom, and this is what we looked at for nitrate leaching and in the soil and in the water. So the dots, the kind of orange and yellow here, represents well water samples that are in the field. So we're just looking at kind of what was just lost to that field at the top of that water surface. And then the purple represents our soil nitrate. So looking at both of those things. So what's left in the soil, what is the concentration there versus the water. And what you can see is that this started in October here. Here we started taking samples in 2011 in December. And you can see that, let's see, this one we had late season application on the red one. So you can see starting in December, this definitely was higher. So that late season application made a difference. We had greater nitrate in that groundwater for that late season, so through October. The yellow represents when we stopped in August. And then around this February time, actually it was in January right here, we applied manure just to the yellow dots, and you can see there was no difference in loss pathways. So that was really important, that after that, we weren't seeing a loss increase in the groundwater. So very important. You see it through the fall. After, in that early season application, we're not seeing a groundwater loss pathway. What we do see is a change in the soil, though, for sure, is that it was pretty similar here. So you're not seeing it. You are seeing a general loss in soil nitrate as the winter comes. That's because it's increasing in the water. So just that is to be expected. And as we went up here, we can see that the soil that we applied to was definitely higher. So we're getting a better conversion rate. There's more nitrate available for that crop because that's the field that we got onto earlier. So you can see it happening there, is that yes, you see it in the soil, which is really important. So you're not necessarily going to see a big split here, but you definitely have more available. The blue in the background represents precipitation, by the way. So that's important to note, that we want to stop in fall, and you see this great increase in the nitrate because we're getting a lot of precipitation pushing it down. And as we continue through the year, again, this is year 2. So this is starting at October here, all the way, here's another October and through the winter. And so you can kind of see, again, we see those dots, and now we've kind of shifted. So now we've got an increase in the loss pathway around this time of year with the yellow. And then it starts shifting back. They join up after February. So we definitely have seen this consistent pattern here. And then on sandy soils, when you apply later, you're going to have a greater loss. And when you apply earlier, we're not seeing those losses, which is very positive, but we're seeing an increase in the soil, meaning that there's more available in the early seasons that crop growth started. And we have a delay when we apply it later. So to be expected. This is, I know, a very cluttered graph. The only thing I want to show here is that this is the depth that we see nitrate. So all it says is that there's more at the upper kind of reaches here. So when we're applying, and there's less lower. And that shifts as it gets through the rainy season. So we get to September, October, November, December, and we see a shift. So this is kind of the upper reaches and the lower reaches. So you can see it go through the profile. You can watch it being lost right below where we know that root zone stops. So it definitely happens. Something like phosphorus, not so mobile, but we do see a little bit of a change as it goes through the year. And this is kind of the whole spectrum from October 2011 through February 2013. And you can see there's not a huge loss. What you do see is with concentration increasing that in the top foot of the soil, there's much more than at 3 feet. So that's all that kind of really says, is we're not seeing those huge loss pathways, but we see a little bit of loss on the top as it gets lost with runoff, but the bottom stays pretty consistent. So let's kind of shift on to weather forecasting, because what we found is that is the easiest thing to look at, and it's the easiest way to prevent having an issue. Because as we've talked here, when we think about the soil types, it was that catalyst that makes the biggest difference. What's actually causing the loss pathway? And it's some type of a rain or large irrigation event. So irrigation you can easily prevent by knowing how much you're putting on, by staying ahead of it. We had a really great talk in irrigation from Dr. Troy Bauer here just a little bit, I guess it was like 2 months ago. Highly recommend watching that one. And he talks about how you need to stay ahead of it. A little bit, a lot, rather than a lot, a little bit. So a good way to keep ahead of that. So now we can talk a little bit more about forecasting. And on our web page, and I am going to go there to show this to you, we've got a great weather section. So if you go to our webpage, Whatcom Conservation District, we've got a whole dairy section, and there's a lot of stuff on here. This is where you can find all the information about that application risk management system, including that worksheet right there, as well as how to figure out what is my soil moisture, what is my forage density. We've got pictures, we've got ways on how to figure that out, how to figure out your water table depth. So a really handy table here for figuring out soil moisture. So depending on what type of soil you have, you can figure out the percent moisture just by, balling in your hand and then figuring out where it fits on this. Forms a ball, ribbons out between thumb and forefinger. Or it forms a weak ball that breaks easily and does not stick. So easy ways to figure that out. But more importantly, when we think about the weather, we've got a whole tab here just for weather. And under there, we've got a lot of different sites that you can go and look at. So when you're looking at what is the forecast, we've got a handful of different ones you can look at. I'm going to show you one in particular that works extremely well. And we've been testing it since 2009 for accuracy. And it's actually, when you give it a normal margin of error, it's like right on about 75% of the time, which is pretty good. And within a small margin otherwise. You can look at current weather conditions from WSU. Previous weather events, if you want to look at historical. We also have rain gauges here if you want to measure the rain at your farm. And then some of the long-term forecast and discussion. This WSU Ag WeatherNet is awesome. They'll send you an email once a week talking about like the week, like long-range forecast for the next week. And it's pretty darn accurate. It's pretty good. So that's a nice thing to pay attention to, just to give you an idea of, is like this rain here to stay? Is it just a short one and it's going to go away? They're very good at being able to describe that and predict it. So this NOAA detail, this is what we recommend when you're looking at, okay, what is the 4-day forecast or the 3-day forecast that I want to look at? Is it going to rain? How long? When can I get out there? When is there a big event coming? Should I worry? This is a great place to look at. So what you can do, just so you know this, is you can customize this for your location. So down here, wherever your farm is, you would just click on the map, and it will readjust the model such that it's now looking at that area. So where I clicked on the map, it's now looking at that zone where that red box is. So very easy to just click and customize your area and then just bookmark that page so you've got it. You can get this on your phone, anything that's got internet service. And you can see that it gives you the precipitation in 6-hour blocks. So it's a very nice way to say, Yeah, they may get a little rain in the morning, but then it looks like it's going to clear up. It also gives you the chance of precipitation, and also important, the temperature, the cloudiness, relative humidity, and the wind speed. Wind speed's good if you're using big guns. You don't want to have anything over 10 miles an hour because your drift is going to be pretty significant. So that's good to know what type of application equipment you're going to be wanting to monitor. So if it's raining today, you may find out, well, I've got this nice clear block coming. I can wait it out a day or two. So this is a great, great weather site to be able to look at. It gives you so much great information on your temperatures, etc. So going back to the presentation here, as I mentioned, you've got all sorts of things now. If you have a smartphone, there's a bunch of different apps. Newly is one you can get 5-minute, 10-minute, 1-day forecasts in your little zone. It'll tell you exactly the weather near you. It's pretty cool. NOAA also has an app, etc. So there's a lot of different sources out there. The ones we have on our website are ones we've tested and looked at, and we can verify are pretty darn good. What we have created based on the forecast is a manure spreading advisory, an easy way for you to just go and look exactly what is my forecast, in other words, for spreading manure. Is it high, is it low, etc. And this is from January, this photos, and they're very colorful that time of year. And basically what it does is it gives you 4 days. It gives you the 24-hour precipitation, so you can say, wow, today I'm getting ½ an inch of rain. That's a lot. It also gives you the 3-day, meaning it kind of, you want to know 3 days out because that's usually the probability time that you've got for a runoff event. So you may not have 0 rain today, but tomorrow they're predicting an inch or so. You don't want to run and get out today just because it's 0, because tomorrow it's all gone. So you definitely want to look at that 72-hour block. Very important. When is it high? Is it going to come down? Here you can see, like today, a very high risk. But in 2 days, my risk comes down quite a bit because that event is going to be over. So I'm going to plan ahead and wait it out a couple days. So this sometimes will go the other way. Today it's low, but in a few days it's going to be high. If you've got that 3-day block, you're all right to get out. It's looking ahead. So knowing how to kind of use that. And this is updated daily. Do you have a question? Yeah.
When is 1/10 of an inch or so beneficial to wash your nutrients down?
It is. So like this time of year when we know, so if you look at that 3-day forecast or the other NOAA one, you could say, well, there's just a little bit and then we're clear sailing. It's actually okay to get out right ahead of that, as you mentioned, especially if you're putting out thick manure, because you can get it out and then the rain will just wash it right off that leaf surface and help it get in. So 1/10 of an inch is okay. ½ an inch or 1/4 inch is it could be too much. But the way to figure that out is to use that application worksheet, and it will help figure it out based on your soil moisture and some of those factors when 1/10 of an inch is okay and when 1/10 of an inch may not be okay. So that's where it's really going to help you figure that out.
If it's super dry like it is right now,
oh, you're fine. Yeah.
1/4 inch would be fine.
That's maybe, yeah. So it depends. If you're some soil types, if they're too dry, that 1/4 inch may not be able to infiltrate quick enough and it can run off. It really depends. On a grass, most cases, yes, you're probably going to be fine. But I have to always put in the disclaimer, you may not be. But in most cases, yes. So this time of year, it almost acts as an irrigation event. Like the rain we got yesterday, we had about 0.17 inches, and it was probably awesome for a lot of fields. And had you applied ahead of time, that would have worked out. But it's the knowledge to know when you can apply ahead of time and when you can't. So being able to fill that worksheet out allows you to show, like if someone else sees you doing that, they're like, hey, that's not okay. You can say, hey, I filled this worksheet out, and actually it was great. It was a positive thing. It was helping. It was part of my manure application strategy. So it can be a very good thing when done appropriately. You bet. So a few other things that this page also offers is we've got current manure spreading guidance. So this is somewhere where it may give you a written guidance that says a little bit of rain, less than X amount, this time of year is okay. Applying manure ahead of time, thick manure ahead of time would be a positive. Or you know, this time of year we've had so much rain, most soils are saturated, even 1/10 of an inch of rain can shoot it right off of your field, so be cautious. So this will give you kind of that, and I update this as needed, and usually every day during the winter time, so that you've got that information. And then what helps too is having these manure setback distances. So if you do apply a little bit at a certain time of year and we get just a little bit more rain than you expected, if you've got that insurance, you've got that setback distance, then you're probably going to be okay. It's probably going to be enough space in order to help infiltrate that into an area that wasn't applied to. So you always want to pay attention to that. And that's kind of this part, be smart and use those manure application setback distances. And what we have is this is in lieu of filter strips where it's appropriate, so you don't have to have a vegetative buffer per se, particularly if it's a grass field. Your field is a buffer if it's used appropriately. And this was based, we did some scientific evaluation and NRCS recommendations, and you can see that throughout the year we've got a variable distance. So in the wintertime we want it to be 80 feet if you can apply on those soils. So we want plenty of space for that rain event to accommodate soil saturation and crop density and all those various factors. And then it starts decreasing to about 40 feet, and it starts increasing to 40 at the late season, and then somewhere in here it's going to shift to approximately 10 feet at minimum. That's the minimum distance you always want to be from something, just in case. And you've got drift and turnaround and all sorts of things that happen. And so in that shift is going to happen based on the weather. This year that shift did not happen in April. So it rained and rained and rained and rained, and that shift came close to May. Unless you were injecting on a cornfield with specific type of guidance, we kind of gave that. If this, then that. If this, then that. So in that guidance sector on that previous page on that manure spreading advisory, you're going to be able to get that so that you can be able to support good management decisions with your manure application. So summary for these types of things. When should you be applying manure? Well, apply it when you won't have a runoff or leaching event. And to be able to figure that out, you've got the weather forecast, we've got that manure spreading advisory, and you've got that armor sheet. Those three things are going to help you decide when can you apply and to support your good management decisions. In those sandy soils, as we mentioned, your time period is probably going to be January to August. And clay, high clay or silty soils, maybe it's not going to be March, sometimes even June in some areas because of the weather table, but you're going to be able to apply a little bit later in the season as long as the weather permits. So that's a shifter as well, both of those, depending on what percent of your soil has that. And then you also always want to apply field practices. This is always going to help you on the when, is always having cover crops so you don't have fallow fields and we don't have those additional losses, and you can get out there at a little bit different time period. It's going to support a reduction in your nutrient losses, particularly in nitrate leaching. So when you take your corn off, essentially, whatever is left, it's not being taken up by a crop anymore, and it's just going to shoot right through that field. So grass, obviously, it's different. It's always kind of taking it up, or it's a lot slower. But anytime if you renovate a field or if you take that corn off, whatever's left over is going to have a quick loss. And that's where something like your fall nitrate test comes in handy to be able for you to figure out, wow, I had a lot left over. Maybe I need to manage this a little bit different, or I hardly had anything. I did a great job. I should mimic those management practices next year. So that's how you use that test at the end of the year. Just your own kind of report card is also what it's called. Maintaining dense forage by applying appropriately, not having winter kill on your grass. Sometimes that's absolutely unavoidable just due to Mother Nature, but you can do everything you can to help support your forage so that it doesn't happen. Avoiding saturated fields, obviously, not applying on frozen fields. If you see this, you probably shouldn't be getting out there. You're probably going to want to wait, obviously. You could always do vegetative buffers. If you're going to have a fallow field, you're going to want to have to do something like that on the edge so we're not having sediment losses if you've got a water body right adjacent to that field. Don't over-fertilize in the late season so that we're not having a lot of excess over that isn't going to be able to carry over. Solids and things can carry over way easier than your liquids. Where do you want to be applying? Well, apply to the right field at the right time of year. So using that soil type and crop information that we've talked about, using that map that's been created for you for learning about runoff that we're most concerned about in the early season and leaching that we're most concerned about in the late season. Of course, we're concerned about both throughout, but those are your main target times to look at your different risk ratings on your soils. And then using those application setback distances so that you're applying to the right areas of your field. And of course, as I mentioned, those two types of forage versus cornfields, we're going to treat that a little bit different on the where, but important to think about that. And then as we thought about are we more concerned about the runoff versus leaching? And that's very soil type dependent. Yep, some soils we're more concerned about one or the other. So paying attention to that ARM assessment map at those different times for those different soils. How? So choosing that application equipment appropriate for that time of year based on the weather and that field. And the most important thing here is to always calibrate all manure application equipment. If you're using a custom guy, ask them if they calibrate theirs so that you know what you're putting on is going to be the right rate and that you know that that rate has been thought about because you've got your manure tests, etc., to be able to figure that out. So different types of equipment are going to be used on different types of crops, and just judging at what time of year based on your soil saturation and various things. You want to avoid compaction in the early season. One good thing to know though with grass, for instance, if you can drive a tractor out there, your soil moisture is probably perfectly fine. So you know that you can probably get out there, and that's a good indicator usually. So again, with the sand versus clay, on choosing equipment in the early season, we want to make sure that you're using something that's going to help that get in there a little bit if we still have very cold or frozen type of soils. And in the late season, we're going to think about probably the same thing. I mean, that's not a bad thing, but most likely you're going to almost be irrigating with your manures, what you should be doing in that late season, matching up the nutrient needs with the nutrient being applied. And then clay, being able to break that up a little bit in the late season to open up that top pore space is good. If it hasn't dried out or if you've kept that irrigated, that makes a big difference too. And then lastly, what type of manure? So we talked about this. This is really hard to do, unfortunately, in our area, picking your thin versus your thick. But you can think about this liquids versus solids if you've got it. So you can also use those two things to be able to mix or customize a little bit. But of course, testing your manure at different times of the year so you understand, is it thin or is it thick? And then looking at, of course, testing your soils, which you do, to match that rate somewhat. In particular, looking at the soil tests, we typically like to look at phosphorus just from a long-term management. So that nitrogen, as we saw, it goes up and it's down. It's all over the place throughout the year, depending on uptake and conversion and loss pathways. So that was a little more tricky to look at, but we can look at trends and we can look at soil types and be able to do better predictors on that to help you match up what type of manure you want at what time of the year. So last slide. So for more information, as I showed you, we've got tons of stuff on our website that talks about all this, that gives a little bit more backing if you want to educate yourself. Of course, you have your planner that you can always talk to. We can put together one of these kind of custom manure application strategies for you. Along with that is, you may have noticed I talked about stopping in August, starting at other times. So you want to think about your storage capacity, and all that relates to is primarily how are you dealing with your clean water? Are you minimizing absolutely all the clean water that goes in your storage, which is what you want to be doing. Your storage is probably going to be fine otherwise. So it's really fixing those gutters, diverting, all sorts of things. You really, really want to think about that. And then eventually here we're working on having a dedicated website just for Washington dairies that will have all this information with that application risk management system. All the different components of your nutrient management plan are going to be online except for your specific information. This is kind of the general stuff about feed management, land application management, etc. And then the setback distances and the spreading advisory and weather. All those things are going to be in one place based on your county throughout the state. So that's in progress. So with that, are there any questions that I can answer for folks? Yeah, Chuck.
Yeah, what pH were you assuming when you made these calculations?
For which calculations?
Well, for putting this risk management matrix together, you must have had some kind of underlying assumption.
Yeah, so, you know, what we assume is that they're at the pH that is generally put for that soil type, right? So they're all, some soil types are better at buffering pH, like a sandy soil versus a clay is going to be more apt to that. And I think in general, we're also hoping that farmers are paying attention to their pH and trying to maintain it at what the crop probably needs to utilize. So whatever pH that might be for that specific crop. So we're assuming that the farmer is managing liming or doing whatever is appropriate for their pH. But that does make a difference. If we look at their soils and we're like, whoa, your soil is really acidic, that means all this stuff is going to be way more readily available. You're going to tie up this, you're going to have all these problems, you're going to have more yield issues, then we're going to have issues with kind of runoff and leaching per se. So the pH is very important to look at from their crop management standpoint for sure. Always something we give advice on if we see it. Anything else? I think many of you have heard this before, so. Well, with that, I thank you for your attention, and I'll stick around for questions, and Susan's also around for questions, and if you take the time to finish her survey and give that back to her, I'm sure she'd appreciate it. All right, thanks guys.